Hello, welcome to the homework solutions for section 15.1 about formulating statistical questions, gathering data, and using samples. Question 1 was about what a statistical question is. So we were asked to write a statistical question and a non-statistical question. So for example, a statistical question could be, what is the top 3 favorite cereals for students at your school? Or something like, how tall are the players who are trying out for the basketball team? Both of these questions anticipate variability and require data to answer. A non-statistical question is one in which there is no variability in the question. For example, how tall is Donovan, the center for the basketball team? This is just asking for information about one person, therefore there is no variability in your data you will be collecting. Question 7 is having us use some information about a sample to project what the population would look like. So at a factory that produces doorknobs, 1,500 doorknobs have been produced. To check the quality of the doorknobs, a random sample of 100 doorknobs is selected. This would be the sample. Of these 100 doorknobs, two were found to be defective. Based on these results, what is the best estimate you can give for the number of defective doorknobs among the 1,500? Solve the problem in 3 different ways, explaining your reasoning in each case. The first approach I took was to look at it as though I have this strip that has 100 spots, and of those, 2 of them are defective. So if I was to take this ratio and look at it for 1,500 doorknobs, so now all 100 bins, and I have 1,500 doorknobs split between 100 bins. So 1,500 doorknobs split between 100 bins means there would be 15 in each bin. Seeing that 2 of my bins are in orange represent the defective ones, 2 bins with 15 in each would give me 30 defective doorknobs. Another approach would be to look at it as a percent. Since 2 out of 100 are defective, 2% of my sample was defective. If this is a representative sample, then 2% of all doorknobs are defective. 2% of 1,500 is 30 doorknobs. You could do this by converting the percent to a fraction or by using a percent table. Approach number 3. We can set up a proportion. We know that 2 out of 100 are defective, and we know we have a total of 1,500. So our sample was 100, our total population is 1,500. We want to figure out how many are defective. So I can set up a proportion and solve one of 2 ways, either by realizing 100 times 15 got me 1,500, so using equivalent fractions, 2 times 15 would give me 30 defective doorknobs. Or I could cross multiply and get 100x equals 3,000, so x equals 30. Question number 10 is similar to number 7. Carter has a large collection of marbles. He knows that he has exactly 20 blue marbles in his collection, but he does not know how many marbles he has in all. Carter mixes up his marbles randomly and picks out 40 marbles. Of the 40 marbles he picked, 4 of those were blue. Based on these results, what is the best estimate you can give for the total number of marbles in Carter's collection? Explain your reasoning and solve in 3 different ways. So my first approach again was to create a strip with 40 spots, and I know that 4 of the 40 were considered to be blue. So 4 of the 40 are blue. If I use this ratio and look at it for the whole strip, where the blue groups represent 20 marbles. So those 4 parts have 20 marbles over 4 parts. So 20 marbles over 4 parts means there's 5 marbles in each of these little rectangles. There's a total of 40 of these little rectangles. So 40 parts times 5 marbles per part means that the total would be 200 marbles. Approach number 2. I could look at it as a percent problem. Since there are 4 blue out of a sample of 40, that means 10% of the sample is blue, or 1/10 is blue. Knowing that the total number of blue marbles is 20 marbles, that means 10% equals 20 marbles. So we want to know what the 100% is. 10 times 100 gives me 100%, so 20 times 10 will give me 200 marbles. I've shown this up here in the strip as well, showing the 10% in orange, and that 10% represents 20 marbles. Approach number 3 would be to set up a proportion. We know that 4 out of 40 are blue in the sample, and we know that in the total there are 20 that are blue, but we don't know what the total is, so we're trying to find the total. So I can either use equivalent fractions to find out that there's 200 marbles, or I could solve the proportion by cross multiplying. Thank you for watching. The images and questions from today's video came from our textbook, Mathematics for Elementary Teachers with Activities by Beckman.